Very good evening to one and all gathered here. So today we are on chapter 3, module number 3. In the previous segment, we discussed about sensors and actuators. This chapter number 2. In connection to that, today we are going to see about chapter number 3, different types of mission control system. First of all, let us understand what do you mean by mission control. What are the special features present in that? We will discuss in detail. So microprocessor is considered to be the most important electromechanical system which act as a main power unit for a robotic system. It uses different types of architecture to control the different parts of the movement of a robot, including the sensors and other communication devices. These are typically based on von Neumann architecture, where data and instruction share from the same memory space as used in many computer systems. What are the key architectural components present in the microprocessor? Arithmetic logic unit. It performs basic mathematical and logical calculations, which is one of the most important factors for controlling the movement of the robot with the help of processing the sensor data. Control unit. It interprets and understands the instruction, and accordingly, it will try to manage the flow of physical information or data by confirming whether the robot performs the intended actions or not. The memory registers. High-speed memory storage areas are used for temporary data handling and instruction processing. And regarding memory, the microprocessor stores both instruction as well as data for the robot operation, ranging from simple read-only memory for basic functions to random access memory for complex tasks. Input-output interface system. It allows the robot to interact, that is, the microprocessor allows the robot to interact with the external environment with the help of the sensor input and controlling the mechanical actuators. What are the different types of microprocessor and microcontrollers used in a typical robotic system? General purpose microprocessor, it is used in many diversified robotic applications, say industrial robot and mobile robot, which offers better flexibility and adaptability to the environment. Microcontroller, it is optimized for better embedded system. They are often used in simple robots with specific functions with a better efficiency and low power consumption. Application-specific integrated circuits. It is highly specialized custom designed chips tailored for only specific robotic task, which tries to maximize the performance and also the power efficiency. See, here are some of the typical examples given for various types of microprocessor. The first one is a ARM type microprocessor. Is widely used in robotics due to the low power consumption and efficient architecture, normally suitable for battery operated robots. Intel processor. It is one of the powerful processors used in complex robots with advanced computational needs, say autonomous vehicle. Field programmable gate array. It is a reconfigurable hardware system that can be programmed to perform specific job operation. What are the advantages of microprocessor in robotics? Enhanced flexibility. We can able to reprogram to perform the various wide range of tasks. Adaptability. The program skills allows them to be adapted to various changing situational environment and moreover cost effectiveness. So the microprocessors are relatively inexpensive and readily available in the market. And it is one of the most important fundamental component in the operation of robotic system. It enables control, computation, and interaction with the external environment. Now let us see program logic controllers. What is the basic principle and operation of program logic controller? PLC is a digital electronic system that uses programmable memory to control various industrial automation processes. It operates by reading the given input, executing the program logic, and then updating the output based on the input from the program given. The PLCs are used in various industries for automation and control that even replaces the traditional hardwired relay system. Here are some of the detailed explanation was given here. Input stage in PLC. The PLC receives the data from various sources such as sensor, electric switches, and other input devices. These inputs provide information about the current state of the process, and then it will try to handle both digital and analog inputs. Program execution. The PLC's CPU, Central Processing Unit, executes the user program logic. This logic very well defines how the PLC respond to certain input condition and determine the appropriate output action. Next one is output state. Based on the program execution, the PLC will try to update the output states. These output control devices like motors, valves, and lights. So the output ensures the control the process operates according to the program logic. Scan cycle. The PLC operates in a continuous scan cycle. It will try to repeatedly sample the reading input and it will execute the program by updating the output. So this scan cycle will try to confirm whether the PLC responds to the updated changes in the process with respect to real time. So in essence, the PLC is a digital brain of industrial robot which continuously monitors the input by making necessary decisions based on the program logic and controlling the process through the output. Industrial automation system. So the industrial automation system basically rely upon program logic controllers. The PLC program involves creating and maintaining the code that instruct the PLC controller to perform desirable action by monitoring the input and controlling the output. Basic PLC program concepts include understanding various inputs and output and the use of programming language like ladder logic so we can execute the output with the help of that. The PLC program involves set of instructions which is used to automate and control various industrial processes. So this process uses different types of program language, both textual and graphical, to define the logic for the specific task. So the PLC uses various program languages like ladder logic, which allows for the control of creation of control sequence that automate the task. Here, what are the basic input and output? It receives the information from sensor switches and use that information to process the output with the help of the motors and actuators. What I mean by a ladder logic program language? It is a common program language used for PLC. It visually represents the control logic used by various runs and elements that reassemble the electric circuits. Control logic. PLC uses control logic to determine the particular action of the PLC based on the input. This logic can be either simple or complex phenomenon depending on the real-time application. So thus PLC are considered to be one of the main essential key part of the industrial automation system, which try to streamline each and every process by improving the efficiency through automation enhancing the productivity in various industrial settings like manufacturing and nuclear power plants, etc. So with this, I thank each and every one of you. We will meet in chapter number 4, the next meeting. So thank you once again.